Welcome to the session. Greeting of the day. In today's class, we are going to talk about the applications of NDT techniques. In previous lectures, we have seen the applications of railways. We have seen the applications of nuclear plants such as power vessels, boilers, and chemical industries. So in today's lecture, let me concentrate on the applications of NDT techniques in aircraft and aerospace industries. Previously, we have listed out a few important top 8 NDT techniques. So these things we have already know. The main important techniques are as visual, liquid penetrant, magnetic particle, eddy current, radiography, ultrasonic, acoustic emissions, infrared thermography. In continuance with that, we are going to see these various applications. In the applications of NDT, we will see the aircraft and aerospace industries now. The role of NDE in aircraft and aerospace industry is considerably influenced by the following features of design and applications. What are they? So we know aerospace and aircraft all belong to a specific targeted industry. It means it's going to fly. We have more difficulties to take material to fly there. So some aerodynamic principles are there. So we have to use lightweight, but we have to take more peoples. Also, it costs more. So at the time, the design is an important factor which is going to affect. So there we are going to do inspection. So what are the first we should know, understand what are the factors are there, what are the features which affect or which influences this design and the various applications with respect to load factors. So number one on that, it is nothing but a selection of materials, and what on the material, what manufacturing process we are going to do. It means what type of welding we are going to do there, what type of assembling technique we are going to do there, because those materials which are going to fly should not be damaged due to those temperature differences or pressure differences in the air. So based upon the designs we have to do. The selection of materials and the manufacturing process is dictated by a design requirement of a high specific strength and stiffnesses to be the properties. This means that component have to be the point we came, what we talked now. It's to be a light in weight to fly, and also it should take a highly loaded to fly. So all these things affects directly this design, and design reflects in the manufacturing processes. So these things and all to be kept in mind. It means nothing but a selection of material and process. Tolerance for design stimulated properties, dimensions, size, and distribution of defects is very stringent. So all these things will happen. Maybe the dimensions, maybe the size differences, and distribution of defects during the manufacturing processes. All things will happen here also. That is what we are. It means the inspectors, the NDT, who makes inspect and maybe repairing or maybe the replacement, depending upon the requirement, depending upon the specification of the defects, permissible, non-permissible, the range, what it is, permissible limits. And the second one, the conditions, influencing factors. First we have seen the selection of materials and process. Second one, we are seeing the environmental conditions. What are they? Maybe it definitely it will corrode because it's completely in air. Moisturizers will be there, rainfall will be there. So all these things the aircraft should survive. The aircraft and the aero engines components operate under cyclic loading and are prone to fatigue crackings. Therefore, further, components are subject to hostile environment of maybe the corrosions and also the erosions and extreme temperature variance. The temperature where at the ground level, at ambient conditions will be differ from the temperature what we are taking at the higher weather conditions where we are flying. And similarly, the lightning strikes also. The third one, selection and also these weather conditions and how far we are using those components, how far those using this material, loading conditions, and its serviceability to the where the failure occurs at what limits. We have to use the proper material, maybe what steel, aluminum, or each and every material has its own serviceability. If we are reaching certain limits, it will melt. Melt means I'm just giving some examples. So accordingly, some properties will differ. For for steel material, 723 degrees is a critical temperature. We should not reach there. Otherwise, the material's property will differ. BCS to FCC will form. Definitely, magnetization property will change. Those things all there. For example, so accordingly, each and every material will have what material we are using there. Those things to be keep in mind, and its serviceability, usages, working conditions, or load factors. So accordingly, we should plan our influences. Accordingly, we should plan our NDT techniques to be subjected there. Particularly for aircraft and aerospace components, there is an increase in usage of as of now. As of now, we are using composites, form honeycombs, and sandwich structures. All these things we are keeping in mind to reduce the weight and increase the strength. In view of these features, every component need to be carefully examined, yes, and to be certified before assembly into the systems. So all these things are assembled to convert a simple single components into a complete aircraft. So there we need joining process, there we need assembling process, and therefore we need NDT techniques to inspect. So these are one of the influencing factors. During service, aircraft and aero engine components are monitored periodically and for continuous serviceability through their useful lives. So it came here through their useful lives. How long it will be survive, or maybe how long it takes to corrode, how long it takes to erode a 1 mm thickness of a material coatings, or how long the painting coated over there will be removed due to this rainfalls or due to this weather conditions. All these things are related to the serviceability. Now let me come into other factors. The selection of NDT techniques. Now we understand what are the factors affecting this aerospace. Material, process, environmental conditions, and we say at last we have seen the usability and the serviceability. All these things are the affecting important influencing factors on the aircraft. Now how we have to select these NDT techniques based upon these applications. So selection based upon this the same factors only, the test environment and how we are assembling conditions of process and procedures, and require a defect sensitivity, how far it will be sustained. So test techniques are required depending upon some three important process conditions. What we are doing, we have to detect first through the technique, right? And then we are wanted to locate where exact point of locations, and then we have to evaluate whether it is in range or specifications or permissible limits, or we have to repair, replace, or reject. So these things and all we have to keep in mind. Therefore, the defect damages before it becomes a major problem. So we are detecting when before it is getting a major problem. Where we are locating, we are evaluating all these things we are done before it is become a major problem, because a crack initiated will be elongated day by day depending upon the load applied. If you are periodically we are going for inspection, we will find a crack in immediately. Then obviously we can able to remove those or repair those crack zone. So in such a way we can able to sustain those material property. To examine and to evaluate a surface and internal defects extensively, used methods are. So we are see here we are using the various earlier already studied 8 methods. All came here. We are using all these methods in the aircraft as like in the railways, as like in the fabrication of pressure vessels. The same method is same, and how we are choosing, that's important here. Where we are choosing the visual, where we are choosing radiography, all specimen depending upon the surface defects or subsurface defects. So depending upon these factors, we select those methods. See the same visual inspections, radiography, ultrasonic, magnetic, liquid penetrant, and eddy current tests are chosen for evaluating the surface and also internal subsurface defects. It is given. So we also studied in same pattern. What are the surface defects? What are the subsurface defects? Identify methods. In addition to these methods, maybe the acoustic emissions also in usage. Maybe the infrared thermography is also widely used. High frequency eddy current, laser sonography, and holography is also used. So these are the main important NDT techniques, the top 8 methods. Other than that, other methods also they are using. In recent years, a number of state-of-art technologies have developed in aircraft and aerospace industries to do those NDT methods of inspection. So maybe how far we are doing the detection, visualization, we are using some cameras and all, endoscopes and all for this. Automatic dimensional measurements, so measurement not done through manual, so automatic systems are there, laser treatments, laser measurement systems, and also this material characterizations. Among the various techniques developed, the few advanced techniques find increasing applications as non-destructive evaluation to assess the structural integrity and to characterize those materials. Maybe what are they? So we told for in the previous slide we told us for visualization. So the second point for similarly for we are using the image enhancement techniques, 3D printing operations or 3D enhancement models. All we are taking about X, Y, Z axis, the data are collected from the specimens and we are converting. So digital signal analysis, image enhancements, distortion corrections or intelligent data functions. So these are the advanced methods digitally performed to collect more data in such a way we can able to do a precise operations to identify a discontinuity preciously at depth dimensions, and we can able to uh, judge whether it is okay or not okay, whether it can be pass on or we have to go for repair, otherwise the same repair, replace or reject. See, in the aircraft there are a few important serviceability and manufacturability uh, phases are there. So I'm showing you here. See, first we have to create the ideas, then the technology development, then the technology development, then the development of design and aircraft testings finally, and we are releasing the first aircraft. Maybe this number of years you see, it is 10 years, and then it is serviceability ends up to maybe maximum of 50 years. Our human survival average of 70-75 is there. Similarly for the aircraft, each and every aircraft what we are developing after designs and when the aircraft is on road or flying, maybe up to 30 to 50 years it may will. In between it is a service, serious productions are there, then a service with airlines and customer services, spare parts production, because it causes a repairing, so immediately those things and all we have to do. So total lifetime of aircraft may be 35 to 50 years. So this is the flow chart of the aircraft. So in these 50 years we have to manage a cost and we have to manage effective working. It means without proper damage should not come. Therefore all these things considerably we have to do proper inspection, then the serviceability number of years can be increased, otherwise it may be 10 to 15 years or 5 years, because it is getting damaged, we are not done properly. Therefore all these things are increasing the decreases the profit, increases the cost of the, again we have to go for a new flights. So some of the images I would like to show you here, how far they are involving in the inspections. See some people are working around there for doing ultrasonic inspections and here and there. The setups you can see. So here a visual test is done. Here we have a video digital camera. In such a way, a boroscope wire, see, a boroscopic wire is through hands they are taken into the engines, and then they are, because it is non-accessible zones in the tightly packed engines are there. Therefore, we are trying to find the defects, discontinuities through using a visual inspection aid methods of such as a boroscope. So this is one of the image you can see. So this is how he is having a video camera or otherwise a digital imaging device. So that's why he can able to identify. See, one of the employees doing engine inspections over there. It's a flight and he opened those engines and doing inspection. Some how far they are doing. Now we come to a next part, applications of NDT techniques in automotive industry. Previously we have seen about railways and then the pressure vessels and then the aircraft. Now as of now we are entering into the automotive industries, a car, mobiles, phones, moving of mobile means moving operations, not a mobile phone. Moving vehicles that we are going to see, that is what automotive moving. Automotive industries were using more than 80% of steel for fabricating automotive parts, and conventional welding methods are producing the body structures. After the parts are made, we have to assemble, we have to link one to one. If we are linking, joining word it comes, definitely it is welding, definitely it is a heat, definitely it is a rapid heating and cooling treatments, which leads to structural changes, property changes. First, now we want to understand what are the demands and conditions, like we have seen in the aircraft, lightweight, weather conditions, environmental. So similarly here also in the automations also we have demands. Some conditions to be influencing factors are there. The situation has undergone a drastic change due to the following reasons in the automobile industry. They are, the industry has become highly competitive, much more brands are there now. So there is definitely a competitions. Hence, a cost effectiveness become a major production strategy. So we have to give at low cost with a maximum quality. So that is one of the competition, because many more companies are there to compete whether it is a low quality or is a high quality, some product they are delivering to the customer, and we also purchasing without knowing its serious damage factors. So but there we have to entity plays the role. We have to be cost effective. At the same time, we have to give a good quality product. With respect to that, we additionally increase the production, because customer satisfaction is there when it is a good quality at low cost. Then obviously, due to words of recommendations or otherwise, obviously the good quality of product when we are selling, it increases the production. We know those what are the factors, recommendations due to good quality, everything, advertisements, all things are dependent. So our aim to give a quality product, when it can be possibly when we are doing a proper inspection in the design stage itself, not at the production stage, not at the fabrication, because fabrication it's a direct physical components involved. So we have to do proper inspection at the design stage itself. Then obviously we can able to reduce the cost of production. Obviously we can able to increase the material property, and we can able to satisfy the customer. There is a demand, second point, there is a demand for increased safety and also the confirmation of the strict environmental regulations. Now and all the pollution is an important factors. So those four, pollution is one of the cater, and also one of the safety also importantly everyone is saying, not only the designs, the style, moving very fast, and the facilities, luxuriness. Out of all, the safety is first important. Life factor is important. So people say for that those factors they're giving ready to give invest money on their vehicles for it is individual safety. So those things also we should bring into the consideration factors. Uh, all things first point is important out of all cost effective. There is a again there is a desire to fulfill the needs of the car owner, the customer, for more luxurious features. See, competitiveness came, less cost came, safety came, environmental conditions came, at the same time luxury also came. So there's a demand for the same point what we have seen in the aircraft. You see, lightweight design. See, this is lightweight design to save as much as important the problem here to save petrol and diesel as possible. Right? These are all increasing day by day problems, cost of the petrol and diesel. So definitely we should light and weight vehicles to be invented. So all these things are related to our inventions. If it's new, definitely NDT also to be newly invented, and we have to subject it for inspection of the components. So these conditions, what are they? I told you this cost effective, safety, environmental regulations, lightweight, and to save those things, petrols and diesel conditions. What we are doing, these demands have necessitated the use of innovative design approach. Definitely, it means lightweight new materials we have to do, such as aluminum, magnesium, or lightweight materials we are adding in the material, adding in the automobile industries, in the cars and bikes. So new joining techniques also developed. So for new material is there, old joining method will not be helpful. Normally we do in welding, steel weldings or do SMAW, TIG, MIG processes. But new materials of aluminum, magnesium are low welding points are there. Therefore, we have to develop a new welding methods, or otherwise the new parameter conditions, the current voltage conditions, and also new filler wires. What material can be added to weld a dissimilar material joining process? All these things are new. If it is new, definitely whatever it is, we have to do inspection at last. But it is difficult to find the error, discontinuity, because it is new. We have to do practice and we have to find. So new technique coupled with higher lighter materials like maybe the aluminum, magnesium, adhesives and composites. Therefore, this innovation takes place in what are the fields? So this innovations are takes place in, we can conclude here, lightweight material inventions, new castings and welding technique as because of lightweight materials we have created there, and then innovative design features based upon all these materials and welding. We have to do weld maps, design features for connecting all the assembling parts, dimensions, all these things we have to do. All these innovation necessitates the introduction of a comparatively a new methods, a compensatory new NDT methodology during a manufacturing and maintenance in service options. We have understood various techniques. So somehow we have given some what are the techniques available for us. It's a new or do some this automobile inspections. The examinations are very carefully we have to do. It means we have to do ultrasonic testing we can take, or there is a radiography techniques we can take, or maybe visual, but we have to do carefully because each finding the defects reduces the cost and improves the quality. First, ultrasonic testing methods. The examination of welds and adhesive joints of metal plates. Maybe welds we have done in the steels, adhesive joints are done in the metal plates of plastics and polymer materials. And a combination of steel and polymer materials and glass has led to a application of high frequency ultrasonic ASI and CT scans are trying to do for that obtaining the soundness of the joint. So one of the ultrasonic method we are trying to do the inspection. Maybe the radiography also we can use in automotive industries. The inspection of aluminum and lightweight materials like magnesium castings and fiber reinforced composites is carried out by film radiography method and computer topographic ideology methods. Radiography allows the detection and the location of defects, like all subsurface defects are possible in the radiography. We know this. And surface 2. So maybe the porosity, shrinkage cavities, and the determination of the internal wall thicknesses are always internal defects, always a mismatching of the materials, everything you can able to find through this radiographic testing process. So low kilovolt radiography is used to examine fiber reinforced composite analysis. A visual inspection is most commonly used method also. Not only this ultrasonic and not only this radiography, visual inspection also we can able to do in this automotive industries NDT technique, as a NDT technique. So various techniques we can do. Maybe ultrasonic inspections, maybe other various technique also we can able to do. So tubing, panels, forged components, and the supplier with the pulse echo technique we can do. Automated methods for monolithic CFRP components with US through transmission, partly manually using pulse echo techniques. Some techniques I'm telling here in the ultrasound technique. Adhesive bonded components are metal or honeycomb structures or sandwich thickness can be done with ultrasonic through transmissions. A thick welding seams with the pulse echo technique also we can do. So adhesive bonds, or maybe the welding conditions, or maybe any sandwiched plates, or maybe any tubes, panels, or forged components, all can be done through this ultrasonic test methods. It use US, it means ultrasonic US. We are using the a shortened word. So visual inspection is most commonly used method, and that penetrant crack inspections we can do. All machined components made from aluminum and titaniums may be subjected to this penetrant of cracks. Magnetic particle testing also we can do for surface inspections, and it is based upon successful of ferromagnetic material because it is a magnetization technique. Or maybe the tapping test we can do knocking manually or semi-automated, all sandwich components we can do. A resonance test, a Fokker bonder test, all metals adhesive bond joins some sandwich components we can do this resonance test. Eddy current we can do, or maybe the X-ray radiography we can do. So electrical conductivity measurements of aluminum alloys, determine the heat treatment conditions, or to measure the layer thicknesses, or for the crack inspections only in the special cases. We can all these things type of inspections can be done on eddy current testing methods. Similarly for radiography also the same sandwich components or forged components or welding seams, the same words we use seen in the ultrasonic also in the previous slide. It means the subsurface defects are possible in ultrasonic and also in the radiographic methods. So therefore, not only those radiography and ultrasonic we are using, the conventional methods other than this also are used for using for defining the surface and also the subsurface defects. It means the topmost 10 methods are there in NDT techniques. Those all can be used here in the automotive industry. That is what the point. So what is our main objective here now? Main objective is to control and monitor the quality. This is a general for not only for automobile, not only for aerospace, not only for railways and preservation. To all components wherever we are doing any manufacturing treatments, definitely the NDT objective is to maintain and control the quality. Next, to detection and evaluation of defects and wear analysis also to be done. Maybe in the friction wear happens, heat treatments, all things. Heat and friction happens, so wear. So that is to be analyzed. Yes. To initiate necessary action before permanent failure or maybe the premature failure has started to take place. We have to find early and start early repairing process. Definition of suitable inspection methods, like for inspection of serious production components, for maybe the for in-service inspections, or maybe the semi-finished product. It means that we have to, our objective is to do inspection at all stages, maybe as a single component from the beginning, or maybe in the semi-finished conditions, or maybe after delivering in the in-service conditions also. We should continuously monitor and control to maintain the quality. This is what our final objective of the NDT. So this is how we have seen about this applications of NDT in aerospace and automobile industries. So the summary. So as of now, we have seen the various applications of NDT techniques. Up to now, we have covered in the railways how it is used, in aerospace aircraft how it is used, in pressure vessels how it is used, and also in the automobiles how it is used. In all these industries, all 8 methods are commonly used. All are all methods are used, but with respect to some surface and subsurface defects, we are to maintain the quality and the frequency of inspections. We are increasing. Frequency means number of times how we are doing the inspections. Maybe in the starting stage, or maybe in the semi-finished conditions, or maybe after finished in the packaging condition, or maybe in the in-service conditions also we are doing. In the next, from the next class onwards, we will try to cover the application of NDT in the offshore gas and petroleum project industries. Right? So the remaining part of the subjects we will continue in the next session. Thank you.